Alrighty. What is the minimum amount of fencing necessary to make 3 rectangular dog kennels that each cover 100 square feet? So we first need to draw a picture of what this might look like. To minimize the amount of fencing, I want the least perimeter. So here's a possible, probably most likely picture of what we're looking for. What you want to think about to minimize fencing is you don't want to make all the kennels separate. You want to make one big kennel and split it up into 3 sections. That is 3 kennels, and don't we share the fencing right here and here? If you made 3 separate kennels, you're reproducing sides you don't need to. So this right here would actually make the most efficient use of fencing. Now we need to make an equation to solve this mathematically. Some of you could do it logically. So I'm going to call this side x. So how many x lengths do I need?
2.
Well, can you see you need 4 of them? Don't you need 4 x lengths? Now I'm going to call the bottom, all of that together, y. So don't you need 2 y's? So what would be an equation for my perimeter in terms of x's and y's? Well, wouldn't my equation be perimeter is the distance around and the fence comes up. But for perimeter, how many x's do I need?
4.
I have 4 x lengths plus how many y lengths do I have? 2 y lengths. Now, don't I want the minimum of this function? But to minimize this function, calculus style, don't I have too many variables? Don't we normally have 2 variables, an x and another number over here? So I got to get rid of x or y. So I have to read the question to figure out how can I adjust this function to make it even better so I could take maxes and mins. So, well, don't we have this information right here that there's 100 square feet area for every kennel? So total, isn't this going to be 100 plus 100 plus 100? So what would all of it added up be? So isn't our area going to equal x times y? Wouldn't the area of space where the dogs can roam, isn't it going to be this by this? And didn't we say the area is going to be 100 plus 100 plus 100? So couldn't I rewrite this as 300 equals x times y? So that right there is my area formula, which is a true statement from my information. But isn't this my primary equation, the equation we're trying to look at? Now watch this. Could I solve this for y and stick it right there so everything's in terms of x? So watch this. I'm going to solve this for y. I'm going to divide by x. So I now have y equals 300 over x. And I'm going to take this and put it right there so I make a nice, clean perimeter equation. So I'm going to put it right here. Now I have perimeter is equal to 4x plus 2 times y. And what did we replace y with? 300 over x. Now what I have here is a perimeter function with only x's. Y's would make it too complicated. You couldn't graph it, could you? Could I technically graph this and find the minimum value of this? Isn't that what we're looking for? The minimum perimeter? Now, since I don't have a graphing calculator maybe available, can we do this with calculus, with extremas, critical numbers, and find the minimum value of this function? The key is creating a function and finding its minimum. And that right there is my function. That is the starting point. All of this just helped us create the equation. Now that we have the equation, we are now going to try to find a minimum amount of fencing, a minimum perimeter. So in order to find the minimum of this, we need to take a derivative and find critical numbers. So let's first rewrite this. Look what I'm going to rewrite it as. 4x plus 600 x to the negative first. I might have confused you there. But can I take that in x and bring it to the top and make it a negative? And multiply those. Isn't this a lot easier to take a derivative of? So I'm going to call this p prime is equal to the derivative of 4x is 4. And the derivative of that is negative 600 x to the negative second. Now, can I rewrite that as well? Yeah, let's rewrite that. Isn't that going to be 4 minus 600 over x squared? And don't we want to set this equal to 0 to find critical numbers? So I'm going to take 0 equals 4 minus 600 over x squared. And I'm going to solve this to get critical numbers. Now, there's different ways of solving this. Could I move this over and do a proportion? Or could I get a common denominator and set top and bottom equal to 0? There are different options. What I'm going to do is I'm simply going to add this over to the other side. Can I make 600 over x squared equals 4 and make a proportion out of it? Can I put 4 over 1? Again, sorry if I lost you. Then I add this over to this side. And now can I cross multiply and solve? So if I cross multiply and solve, I now have 4x squared is equal to 600. Divide by 4. X squared is equal to 150. Square root. So x is equal to plus or minus the square root of 150. So x, to find my either minimum or maximum, we don't know yet if that's a min or max. It's one of these two. My min or max, relative min or max, are one of these two. Now, which one doesn't make any sense for a measurement of a side? The negative's preposterous. So out of logic with these optimizations, you can throw values out. So aren't we looking only at x equals square root of 150? Now, what about is that? Let's just think, to help us with number sense, isn't the square root of 144 12? So won't this maybe be like 12.1 or 2? I don't know, 12 point something. That just helps for number sense. We want to use the square root of 150, but we know it's about 12 point something feet. Okay. Did we answer the questions? Is that my answer? No, you gotta, that's what people mess up. They think they're done, and that'll be a choice on a multiple choice. I'm done. No, you're not. You want the minimum amount of fencing necessary. That's just one side. How do you go and find the actual amount of fencing? You have to plug this into which function? Over here? One of these? Or this one? Can I plug it into this one right here? But before I even do that, do I have to verify it actually is a minimum? What if it's a maximum? Then I'm kind of having more problems come up. Now, is it probably a minimum? Hopefully so. Hopefully. But we have to check, and then once we check, we're going to take this and plug it into the original function to actually find the perimeter. So how do you check to make sure it actually is a relative minimum? It's called second or first derivative test. We get to choose. Isn't the derivative of this going to be pretty easy to find? I'm going to use second derivative test. So what I'm going to do here is I'm going to kind of cross that right there. And I'm going to come over here and I'm going to do the second derivative. It's going to be, the 4 disappears. That becomes a positive 1200 x to the negative third, which is equal to 1200 over x cubed. Now, could you easily plug in this number and just see if it's positive or negative? Yeah. So I'm going to write function notation all of a sudden, just to help myself, just so I can see it. Is that okay if I make it into a function notation? And I get 1200 over the square root of 150 cubed. Now, do I care about the value of this? No. That's positive. Doesn't that mean it's concave up, meaning it's a minimum? Now, could I go back and do first derivative test? Could I have used this function and gone left and right of 12.1 something? Mm-hmm. Yeah. I use second derivative test, and the textbook tends to use second derivative test a lot, if you can. If the derivative is really easy. So we just verified this actually will be the minimum value. Some of you could have plugged this in and got lucky. You know, he's like, oh, I just plugged it in. Oh, I got lucky. Ooh, I didn't check. We checked. So yes, this is the minimum. So now can we go back to the original and plug it in? So now we're going to go to the original. And we're going to find P of the square root of 150 into the original. So that's 4 times the square root of 150 plus, or not plus, isn't that minus, what would it be? Minus 600 over the square root of 150. Oh, I'm putting the wrong one, aren't I?
Yeah.
So let's go back here. I'm using the derivative. Okay, what I want here, I want plus, don't I?
Yeah.
So I want plus again. Isn't it 600 over the square root of 150? Don't do what I did.
No.
Okay, don't we put 600 over the square root of 150? Don't do it. I was mixing these up. Make sure you don't do the first derivative. Got it? Don't do that mistake I made. Now, isn't that an ugly number? But wouldn't that be the perimeter if you had a calculator? This is in feet. There's your answer. That's it. We're not going to simplify. That is an answer. Now, if you want to get a calculator out and find the value, go for it. That calculator regurgitated answer is how much fencing you need to go to the store and buy. I'd probably buy more just in case I mess up. Correct? Maybe return it if you don't use it. But that's what we look for if we're trying to find the minimum amount of fencing. If we know for sure, let's say the government said, you have to have 100 square feet for your dog. It's like, whatever, you're forced to. This is what you need. This is how much, and then you can figure out the rest. Good luck.